Just getting the, waiting for people to show up and join us in the Hangout. So we'll take a second. Got Gary Gonella tonight with his telescope, and Cory Schmitz, who's going to be hand tracking Jupiter. Pamela Gay is going to be joining us, and Roy Salisbury is going to be here for color commentary. But Gary, and then maybe we're going to have Stuart go up later, but not some of the other folks. There's Gary. All right, I'm going to go live. So we're live now. Oh, we'll be live in 3, 2, 1. We're live. And now I will let people know. Are you going to embed that on CosmoQuest?
Yeah.
Okay. I will let people know on the Twitters.
Okay, we're now embedded live, and I'm getting ready to tweet it out. Sorry, anyone who's tuning in. This is the stage in the show where you get to watch all of us manically letting everyone else out there know that the show is live. Unfortunately, there's no easy way, in fact, there's no way at all, to know the URL of the show prior to pressing the live button. We wish there is a way around this. There's not. And somebody's telescope is talking.
No, sorry, that's my radio. A friend of mine up in Oregon on the ham radio, he's tuned in and was talking.
Cool.
So we got him here and tried to get everybody from work and told everybody at my astronomy club meeting last Friday that they need to be here.
Good.
Cool.
You got them all to circle you and me, and that's the trick. All right, I have tweeted it. I think. Okay. Awesome. And let's just see if anybody has noticed that it's happening yet.
Yep, we have Mike Rector. He's already there.
Oh, good.
Yep, we have Mike Rector. He's already there. And we have a bad echo suddenly.
Who's the echo coming from? Who's echoing?
I did for a second. It should be okay now.
Okay, cool.
Awesome. All right. And I will check out the...
You're getting an error on the CosmoQuest site? The Daniel L. Rankin? What's the error, and I'll fix it.
Or is he getting an error here? How could he say that he's getting an error?
Yeah, that's true.
No, seems to be working for me. All right.
Okay. I have it working perfectly on the CosmoQuest site, so that's not the problem. Okay, if anyone has problems, if you can be specific on which site you're which site you're watching from. Oh, weird. Try reloading the page and see if it works.
Well, why don't we get cracking then?
Yeah.
You can keep debugging. So hi everybody who's watching this and everyone who's going to be joining us in the next little while. So again, we're going to do some virtual telescope live streaming. For sure, we've got Gary Gonella in Los Angeles area with his beautiful 14-inch fast star setup telescope, and he's got a hit list of deep sky objects that we're going to be checking out. And Cory Schmitz has is kicking around as well. I think he's wrestling with you right now, but he was getting us some views of Jupiter. And we might have a few more people joining us tonight. We've also got Dr. Pamela Gay, who is my co-host on Astronomy Cast, and Roy Salisbury, another one of our astronomer friends who is away from his telescopes but is going to join us for color commentary. So can we see you, Gary? Are you there anywhere?
Yeah.
Back to you?
Let me find the right screen to switch.
And if we switch away from the telescope view, will we ever be able to switch back?
I hope so. There I am.
There you are. All right.
The purple me.
Bathed in the glow from your computer screen. So awesome. Okay, great. Well, that's enough, Gary. Let's see your telescope again.
Okay. I'm all for that.
Okay. So you actually instead of falling victim to my sort of spur of the moment schemes, have decided to prepare us a bit of a hit list tonight. So did you want to give us an idea of the agenda? What were some of the objects that we're going to hope to see tonight?
Well, what we're looking at right now is NGC 2264, and the object at the left is called the Cone Nebula. I don't know if it has a separate designator, but this whole nebulosity region. I've got the Hubble variable, which we may or may not be able to see with my scope. I haven't looked at it. We've got Flaming Star Nebula, Thor's Helmet, Teardrop, Rotten Egg Nebula. That one may be too small.
You just decided to go for all the things with curious names tonight.
Yeah, everybody has seen Orion and Andromeda, and I just sat down the other day and said, let me look at this. Let me see what we can come up with.
Yeah. Well, I want to go back to that Horsehead Nebula, and I do want to get a view of the Orion Nebula and Andromeda. I mean, I know we've done them, and the Horsehead, but they're still phenomenal. So now all those nebula that you were mentioning, they're not in this one view, are they? This is just This is the Cone Nebula. Okay, all right. So Pamela, do you want to give us some science here?
So this is. It's the Cone Nebula. It's an object that is located about 26,000 light years away. So what we're actually seeing is star formation as it appeared 26,000 light years ago. That's not that exciting because this object really isn't evolving that quickly. So if you went and visited, it wouldn't look too different from what we're seeing right now. What we're seeing is a region with a lot of young stars. Their light is going through the cloud, and as it does, it's getting bounced in different directions. We're seeing the red emission. We're seeing pockets that are lit by stars inside of them in the process of forming. We see knots in the gas and dust from the shock waves from the young stars have massive winds coming off of them. And it's just amazing to see all of this structure is due to the violence of starbirth.
And what kind of an exposure are you doing right now, Gary?
That's 2 minutes.
That's a 2-minute exposure. Oh, that's one of the longer exposures that you've done.
Right, and that's through the hydrogen filter.
Now I can see that the background is actually starting to get pretty white. I guess it's because you're doing such a long exposure. Is there sort of a way to keep the brightness on this a bit, just to see the difference? Yes. You were stretching it before, right? Like so
that's what I'm doing now. There's a high contrast.
Yeah. Oh, that's really good. Now, but Pamela, is the Cone Nebula just that object over on the left-hand side that really looks
right.
like...
So the cone is just the object on the left. The number, the new galactic catalog number 2264 applies to the entire system. So cone is over on the left where it looks like one of the stars blew something clear. Now that's actually just an optical illusion. It's not that that section is blown clear of material, quite the opposite. That's an extremely dense area of molecular dust and gas that's actually blocking all of the light from getting through it. So that's an area of blackness, not an area of emptiness.
And you can see, look at all that faint, like I hope people can see this okay when they're watching. You can see these really faint just nebulosity all throughout that whole region. Just phenomenal.
Yeah, I've got another computer running here where I'm looking at the regular stream, so it's not quite as good quality, but most of it's there.
Oh, there's Cory. Cory's joined us, and Cory is sort of. You're going to see the other side of the coin here. So Cory. He's got it more in the view there. There it is.
There it is.
So I hope people can see this. So Cory's got a view of Jupiter, which is. But while Gary's got this phenomenal automated telescope that keeps any object in the sky in sort of perfect alignment, Cory is hand guiding his telescope. You don't have any. Is it like a Dobsonian mount? Is it even?
Yes. Here, I'll try and wonder if I can.
That's awesome.
Yeah. So
no, you can't see it. Yeah.
To be clear, so for example, we've had this conversation before. So a Dobsonian mount is and they're really just like best bang for your buck. It's where the mount is on the ground, the tube comes up, and it's you can get a very powerful telescope for a reasonable price. But the downside of it is that actually tracking with it is very difficult.
You're steering a cannon. It's my favorite type of telescope, but it's the Earth moves. It's really annoying, and on a windy night, just trying to keep things focused, it's this constant steering issue.
So we can see the bands across the planet, and now I don't know if you can manually control the brightness.
Yes.
But we've been able to sort of see the moons, but we found we have to.
Yeah. Do you want me to get the moons?
Yeah. Can you try and do that?
Yeah.
You got to blow up the brightness, and so the problem is that the moons are very faint compared to the brightness of Jupiter. Jupiter is actually a very bright object, and so what we get is when we try to. You can have one or the other, so you either get the moon or the planet. Although last night I was doing just a test with Stuart, and we actually had Callisto just finishing up a transit in front of Jupiter, and so you could actually see Callisto just hanging off the limb of Jupiter, both in the same exposure.
Callista,
sorry. Callista. Oh my God, rookie mistake.
That's all right. It was a musical reference. It had me confused, but knew where I was going.
Yeah. Nope, Callisto is the name, not Callisto.
Okay, so we're both foobarred tonight.
No.
No? Damn it. Okay, so here's where I have to admit,
One of us
I
is
took
fine.
so much cold medicine to be able to be clear
Right.
that you're not listening to me sniffle, but apparently my brain is gone.
Oh, okay. Hold on. So let's see. We'll go with Jupiter now. Oh, there's a moon. So I don't know if anyone can see, but just in the bottom right-hand corner, if you can lift it up a little further, there it is. I can see two moons. I don't know if anyone can see it. Yeah, it's pretty hard to see them. So maybe we should just go back to the.
I'll get brighter.
To the Jupiter view. Yeah, you want to go a little brighter?
Yeah, I can go brighter.
What size Dobsonian is it? Is it a 6-inch, 8-inch?
10.
It's a 10-inch. Oh wow. Okay.
That's an awesome size.
Yeah, that's a really big telescope.
But
So-
it's a size that can still be easily lifted by someone my size, which makes it one of my favorites.
Right, and put into a minivan. Yeah, I think the biggest Dobsonian I've seen was a 22-inch that somebody had built. And this was one of those ones where you have to get up on a step ladder and climb up to the top and then look through the eyepiece. But I mean, the views are just phenomenal. So.
Yeah, there's some Dobs up at the 30-inch scale or so that you'll start seeing if you go to the big star parties. But the 10-inch is a great size because you can hold the base, you can hold the telescope, and someone my size, I'm 5'6", typical female, they sell out of my size clothes the first day they go on sale. I can pick the sucker up, and it's not a big deal. And I don't have a minivan, but it does work nicely in my Jeep Wrangler. And now we can see moons. Beautifully.
There we go. Oh, all four of them are over on the right. Oh, that's perfect. Oh, that's amazing. Where are you located, Cory?
In the middle of Iowa, in
Right.
the United States.
So you're about 2 hours ahead. Well, you know what? So Mars isn't going to be up for you yet. Probably for another hour or so, right?
Yeah, it's on the other side of my house as well.
Right.
Yeah, I'm in the middle of, I'm right by Des Moines, Iowa, which is the biggest city in Iowa, so kind of in a light dome.
Oh, that's phenomenal.
I've driven through there more than once.
Didn't stop, though?
Probably to eat.
So what's the focal ratio on your telescope, Cory?
F5.
F5, okay. So that's a pretty wide, pretty fast setup.
Yeah, it's been, I just got it in October, and it's my first telescope I've ever owned, so.
Wow, congratulations.
Thank you.
Welcome to the hobby that will, you know.
Sucks all my money and time away.
All your money and time, yeah. Yeah, just talk to Gary. Gary is the haunting vision of your future.
Yeah, absolutely.
And Roy.
Yeah, I'm too old to go bar hopping.
Yeah, Roy's in the middle, I guess, having built an observatory in the Nevada desert. No, New Mexico desert, right?
Arizona.
Arizona, right. Yikes.
It's a desert.
Yeah, either way.
Okay, well, let's go. Let's see if we can see where Gary's at. So Gary, did you want to switch then to another object?
Yeah, I left it here so you can take a look, and I've set the Flaming Star Nebula, IC405 or Caldwell 31 as the next destination. So I will send the scope there.
Sure. And Cory, can you bring the brightness back so we can see the bands on the planet?
Sure.
That'd be great.
If you look in the center of that picture, that's where the what's called it's the Christmas tree cluster.
Yeah.
So the cluster of stars there, and when you had it brightened out, if you tilt it on its side, it almost looks like a Christmas tree.
Okay, I see that.
The cone is like the star on the top, and then you got all the little balls on there as the stars, but sideways it looks like a Christmas tree.
And I am saving all these so it's easy to go back to them.
Cool.
Okay, let's 10 second. Let's try a minute. Okay, you can see a little bit of the flaming star there in the first 10-second shot. This is my frame and focus with the bullseye. And we're going to do a 1-minute exposure where we see quite a bit more.
Yeah.
Let's see, it's all in this area.
Do you know which of those stars is AE Aurigae?
No.
Okay.
Apologize, no.
Okay, let me see if I can find a finding chart.
Oh, there you go. So I don't know if people can see the bands on Jupiter with Cory's view. I can definitely see it in my view, in the Hangout. Looks phenomenal. Yeah. I wouldn't, you could try increasing it with a Barlow, but I can't imagine you tracking it at that point. It would be...
Oh, I can do it. I'm pretty good.
All right. So the Barlow lens is another lens that you put in front of the eyepiece, and it's like a zoom on a telescope, because a telescope doesn't really have a zoom, and so what you're going to do is increase the magnification of the object. But the problem is that once you increase the magnification, then it also increases the speed at which it appears to move through your eyepiece. And so right now the tracking is kind of complicated. Once he puts the Barlow lens in, the tracking will be extremely complicated, very fast moving. So you're the master, Cory. I gotta say.
All right, I'm gonna go give that a try.
Okay, that'd be great. Yeah, because I can see the bands across the planet, but I'm worried that people maybe can't see it on the Hangout. Let's go back to.
Okay. All right. Give me a sec. I gotta go grab the lens.
Sure. I'm just gonna check out Gary's view. Oh, there we go. Ooh.
That's a 1 minute
Oh
of
wow.
the flaming star. Let me. Trying to find the sweet spot right there. There we go.
There.
What filter do you have in?
a hydrogen alpha.
Okay.
So we're just seeing basically the light given off, so anybody knows by excited hydrogen. I don't know what it's excited about, but something.
Yeah, what's amazing to me is I'm looking at it without the hydrogen alpha filter. And if you look kind of towards the middle of the image, there's two bright stars. Yeah, that one and then the one down and to the right of it.
Almost dead center.
Almost dead center. Go
Oh,
in.
To the down on the right or up to the right?
it's like
Down.
I want to point at my screen.
I know. So go down with your cursor. Stop. Go up and to the left.
Ah, right there.
That one, yeah. So that star and the one you pointed at first have a reversal in which one appears brighter in the image I'm looking at because it's through a completely different filter. And the reason that happens is the star AE Aurigae, which I think is the one you're pointing at, is such a blue star that it just doesn't show up that well in your filter. And so that's just an awesome use of filters.
Interesting. Okay, I'm going to do another capture here with the oxygen filter. We'll just see how different it is.
Okay.
Pretty much this list, I haven't looked at most of these.
You haven't looked at these?
No.
What?
It's a big universe, Fraser.
Yeah. I'm always finding new things to look at or
Yeah,
take
but I mean,
pictures of.
the field of view on this has got to be several degrees across, right?
I'm about 1.5 degrees by 1 degree.
Right, so it's about the size of the moon on the sky.
Yeah, the moon would fill the center quarter. I can see all the way around the moon when it's in there.
Mm-hmm.
Okay, I'm doing a 1-minute exposure, and we're at 80%.
So again, this is a region with lots of star formation, and that star I was talking about, AE Aurigae, it's a star that is actually going to blow itself to smithereens at some point, if I'm remembering correctly. Let me make sure I'm not lying. It's a blue O-type star, so there's a very good chance that it's either going to have massive mass loss and end up as a white dwarf, or happily explode as a supernova later on in its life.
Now, interestingly enough, what we're looking at right here is the light through oxygen filter, and I don't see any nebulosity at all there.
Right, because there's just not that much oxygen in the field, and so unless you go forever and ever and ever, you just erased a nebula, which is kind of a powerful thing to get to do.
I feel like God.
It's really amazing. It's like having one of those cereal box things where you can't read the writing until you put the red filter up, and suddenly it's visible. Well, you just did it with blue instead of with red.
Mm-hmm. Okay, I'll get one more capture on this guy.
So that's amazing that there's just like nothing there with oxygen at all.
We see a completely different universe when we look in different colors. This is why we have to look at the entire electromagnetic spectrum. So it's not just a problem of looking at every place on the sky. So we have to look at every place and then look at it in radio, in infrared, in visible light, in ultraviolet, in X-rays and gamma rays. And only by building up this very complicated picture can we actually map everything that's out there. And we haven't. Not at all.
Okay.
And so, so don't forget, if you guys want to ask any questions, we'll be
following Twitter and the comments, so both are open.
Yep. So you can either ask a question on the Hangout itself in Google+, or you can ask a question through Twitter. Just use #CQX #Hangout, and we'll see that over on the CosmoQuest interface. So. Cool.
And if you can +1 this or retweet it so that we know you're out there, it helps us keep track of how many people are participating in these.
Okay, this don't have the fine control I'd like, but I'll talk to him about that on the software. All right, so that's, again, the hydrogen alpha. We're back, and while you're looking at that, I will move to Hubble Nebula.
Wow. So we're done with this object. That's it. We're just going to discard it and move on.
Unless somebody wants to see it more, but the Hubble variable, I mean. And I don't know much about the Hubble variable. I'm not sure. I may have too wide an angle to see it.
This is actually from that other catalog of awesome objects to look at that exists that's more biased towards the southern hemisphere. So those of us in the northern hemisphere, we have the Messier catalog that was put together by Charles Messier, thus the name. And he basically went through and cataloged, along with his observing assistant, 110 objects that were things they kept stumbling across and mistaking as comets. Well, it gets used by amateur astronomers because these are the brightest, best objects to look at through telescopes. And unfortunately, folks in the southern hemisphere lacked having an astronomer who got similarly annoyed and created a similarly awesome catalog. Well, Sir Patrick Moore stepped forward, I think it was in the 80s, and fixed this situation by putting together what's called the Caldwell catalog, where he used his mother's maiden name. And this is Caldwell 46 from the Caldwell catalog. It's an object that can be seen in the North America. In North America, it's a declination of +8, but you can see it through much of the southern hemisphere as well.
I think what's interesting is a lot of these objects are big and faint, and not necessarily the little like comet type objects that would fool you, you know. But they're actually big, and so you can just imagine the telescopes at the time probably weren't easily able to gather, because they were just using their eyes. They were using photographic plates, and so they couldn't gather these big, dim objects that covered big chunks of the sky. They could just spot these little fuzzy bits in their telescope view, and needed a way to keep track of them. And so,
well, all the fuzzy bits looked identical.
Right? Yeah. No, I know, but I mean, these are way different from the small fuzzy bits that people saw before.
Yeah. What's kind of amazing is because we live in a modern era where we detect so many comets, we're able to see all the faint little ones that look kind of depressing through telescopes. But there are these amazing comets, Hyakutake, Hale-Bopp, that are just as big as the nebula we're looking at tonight.
Oh, bigger. I mean.
Well, yeah, no, that's true.
Hale-Bopp, I mean, they just covered, what, like 20 degrees of sky?
Yeah.
It's gigantic, right? Look at that. So what is that?
This is the Hubble Variable Nebula. I'll give you that's a little better view. That one does look like a comet. It's fairly small.
It's illuminated by the star I'm going to mispronounce this. I should be able to pronounce all my constellations. This one has always been a mystery. R Monocerotis. Armon is what everyone actually calls it. This is an object that was detected by Edwin Hubble on January 26th of 1949, so we haven't known that its awesomeness existed all of that long. And the star that's lighting it up is actually a variable star. So if you watch this nebula over time, you get to see the star slowly change well, not slowly, you get to see the star randomly change in brightness.
So I've got a couple of questions here, Pamela, for you. Adam Mill wants to know, are star fields visible in space? So I guess the question is, like, if you're in space, would you be able to see stars? Like, do the astronauts see stars?
Oh, yeah. So it's simply a matter of contrast. Once you're in space, as long as you're not looking directly at the sun and the area around it where our eyes just can't deal with the contrast, you see all the same stuff. And one of the most amazing things is because of the vast distances in space, if you went to Pluto, all the constellations would look the same. In fact, if you went to the nearest star, Proxima Centauri, with the exception of Alpha Centauri and its binariness, all the constellations for the most part would look the same because everything is so far away that it takes extraordinarily long multi-light-year journeys before you start to see things move.
Well, this is too small. Let's find something else, Gary.
Zoom all the
Okay.
way out on that picture. You zoom all the way out.
That's 200% right there.
No, I mean,
There's
No,
400.
there's
The other way.
a nearby system.
Yeah, down in the lower right-hand corner is actually the Cone Nebula.
Yeah, I saw
Oh.
some nebulosity there. Can you
Pointing at the
reposition
screen.
to get that? Or I guess punch in the Comb Nebula into your
Well, we were looking at it before.
Yeah.
It's right there.
Oh,
Yeah,
it's that close. Okay.
Yeah.
Yeah, that's the edge of it. Okay, let's go see what Thor's helmet looks like.
Or
That's
something.
always a fun one.
I just love the names of the things that you
Yeah.
found for tonight. This one is a really hard to observe object. So it's going to be interesting to see how it comes out with your telescope.
It's really small,
Yeah.
but it's really cool.
This
It's
is
also
another
fairly low.
this is another one of those angry blue stars. In this case, it's a Wolf-Rayet star that will explode as a supernova at some point in the future. And as it works on blowing itself, right now it's just blowing off material, and it's created a small nebula around itself. And some of the material being illuminated isn't from itself; it was just there to begin with.
So Adam Bradley wants to know what are you using to show the telescope views online? He says, I've seen cheap webcam-like models, but I assume these are much higher end. No. So the various people participating are using a vast range of objects, a vast range of devices to actually capture their images. Some people use digital SLR cameras, like a Canon, T3 or a 60D or something like that. And there's actually mounts, so you can mount one of these DSLR cameras right onto the end of the telescope, and so there's no eyepiece. There's just your big camera sticking on the end, and then you use the CCD on that camera to gather the image. Other people are using small webcams, fairly inexpensive webcams. The common one is one that's called a two cam.
It's by Philips.
Made by Philips, yeah, and they haven't been making them for a few years now, but they're quite nice for astrophotography, and so a lot of astronomers will use those. There's another great camera called a Malin cam, which is sort of a fairly high-end model camera, especially for planetary work. It's nice because it's color, but some people are using those. There's a few sort of scratch home-built setups. And then there's some specially built cameras that are being used. And I know that, Gary, what's the camera that you're using?
It's a QSI. It's made in Texas, and it's made specifically for this.
Right. And so in this case, Gary, before we even met, had the perfect setup for doing this exact thing, which, he likes to sit in the comfort of his house, control his telescope from, the cold Los Angeles air, and move it around the sky. So
It is 55 out there.
oh, that's just
I'm amazed at what your telescope just did. That rocks, and you can totally see why it's called Thor's helmet.
wow, that is beautiful.
And it looks like Thor's helmet.
Yeah, it totally does. I can see kind of the horns on either side of it, and the way it's
Yeah.
aligned right now, actually, it really does. Can you embiggen that?
I can. You watch The Simpsons, don't you?
It embiggens us all. Oh, there we go. Oh yeah, look at that. Oh, Cory, did you give up your Barlow attempt?
I gave up. It's not going to
Yeah.
work through the web like this.
Yeah, no problem, no problem. Yeah, I can tell people,
And you were talking about webcams. I actually have a $15 Logitech C250.
That's awesome.
Yeah, and so you can take a webcam and stick it right onto the eyepiece, and then it will get the view as well. So, do you have another camera, like a DSLR, or have you only got the webcam? Because if you've got
I've got a DSLR as well.
yeah, if you've got a DSLR, have you ever tried hooking it up as a camera?
Not for a lot of not live video. I don't know if mine can do live video. It's a Nikon, so I'm not sure.
It depends. Like with Canon, they'll have like a utility that lets you see a preview of it on screen, and then you can use that preview and pump that through the feed. Is it a little out of focus, Gary?
Yeah, it's because I'm zoomed in.
Oh,
I'm at 200%, and as I am running the 4x4 binning, so I'm putting together basically 16 pixels on the camera to make each pixel.
Well, it's a lot clearer now. Something happened. So what is this, by the way? Thor's helmet. What is it? Pamela?
Sorry, I was muted. This is an extremely young star called a Wolf-Rayet star. They're some of the more massive stars. They're bright. They're blue. They are undergoing massive amounts of mass loss. They have huge winds pushing clear the area around them, which is why you get that bubble shape. And eventually the star is going to blow itself up as a supernova.
So is all this material just outgassing from this star, this one star?
It's a combination. Some of it is outgassed material, but it's also pushing the normal interstellar media that's around it out to form the wall of the bubble. So it's giving off material, and it's compacting the material that was around it.
Could this material, form other stars or objects? Or
It's just not enough mass.
Not enough
I mean,
mass.
eventually it'll get sucked up and used for something. That happens to everything. The universe is the ultimate recycler, but this nebula is not going to compact down into its own star.
Right. And when it actually finally blows, then what would we get? Something more like the Crab Nebula?
Yeah.
Or right, okay.
Yeah.
And speaking of the Crab Nebula...
You want to go there, don't you?
No. We could.
Yeah,
We've done
no problem.
We could do it again. Well, no, you had an agenda, so I'd like to keep... I don't want to keep you.
It's not an agenda. It is just literally I did some looking, and I know we want to look at the regular objects, so, and any suggestions, look at the crab. I'll pop that guy in here.
Okay, sure. So this is cool. So we're going to go see the Crab Nebula, and this is M1 in the Messier catalog. And what's kind of neat about this object was it actually happened in modern history. So it happened the year 1066, I think, and was visible by astronomers in China. They actually took records of this. And so when this bad boy went off, it was visible in the daytime, and now we're seeing over the last 1,000 years the sort of expanding debris cloud when this star went off.
1054.
1054. Oh. Aaron Lamb has described this as the future of astronomy, no pants required.
I just love that quote.
Yeah, exactly. Wow.
Phil and I are both guilty of being in hangouts where we were dressed professionally from the waist up and wearing pajama pants.
It's a little cold in Iowa to wear pants.
Yeah.
I hope you have a good pair of Carhartts.
Nope, thin jeans.
Oh no. Okay, we need to raise money to buy our observers Carhartts.
So was there anything else in your view, Cory? Can you, with your setup, you probably have a pretty good view of Pleiades, which is kind of close to Jupiter still, isn't it?
Yeah, it is. The only problem with that is I can't zoom out anymore. So I can really only get a couple of stars in the field, and then
right. So you can't
it's not very interesting.
Yeah. I'm trying to think what else you could get. You could get Orion.
Pleiades.
Yeah. Well, that's what I said. You could try Pleiades, right? But I mean, he's got Orion.
Hyades?
Hyades? Yeah. Could you get like the double?
I could get one of the brighter stars and Hyades and see if I can even see anything. Sure.
Yeah, you probably need a bit of a wider field of view. But I really like the color cameras for seeing the star clusters, because then you just get the beautiful coloration in the stars. So if you want to take a crack at the double cluster, that would be great.
I was looking at that earlier, but I haven't tried with the webcam yet. So.
Cool.
I mean, you've got an F5. That's a pretty wide field of view, though. I think you'll be able to get it. I have confidence in you. So there you go. So there's the Crab Nebula. Look at that.
That's a 10-second shot. I'm presently downloading a 60-second.
And it's all washed out.
Yeah. Well, that's because I had it all set for the 10-second exposure. Then we do this and that a little bit. There you go.
Oh, perfect.
So the question we just got from Dave Gallant is, have we had any Malin cameras on? I don't think we've had on this show yet, but I've been talking with some of the folks at the, oh, I wish I didn't have a head cold, at the Online Astronomical Society over in the UK, and they have Malin cams, and they're interested in partnering with us. It's just a little insanely late at night right now over in the UK. So we'll likely do star parties with them when it's earlier in the day here in North America, and we'll be making the people in Oz curse themselves.
We've tested a few Malin cams. I don't think we've brought one into the star party. They're a little tricky to use. All of the controls for the Malin cam is all on the camera itself, and so a lot of the times, if you see, you know, we're asking Gary to do a lot of like brightness swapping and, you know, zooming and moving around and things like that, and it's a, you know, from what we've seen, because it's all actually on the camera itself, it's kind of like, I don't know if you've ever like programmed your television, you know, with only the controls on the television, and you're like having to switch buttons up and down and move things around. In case it's kind of rough. So you know, in the work that we've done with one Malin cam, we had the view was beautiful, but it was kind of hard to get it sort of switching from object to object. But definitely, I mean, you know, anyone who wants to live stream a telescope into these hangouts is more than welcome. I mean, you know, we're glad to have everyone's help.
If I can do it, anybody can.
Yeah. And I think we're going to settle right now for sure on Thursday nights. I think we're going to try and aim for every Thursday, kind of 6 o'clock Pacific to 8-ish Pacific, to try and do these, because up until now we've done them very sort of at the seat of our pants. You know, whenever one astronomer says, "Hey, I've got a good view," then we go live. And I think we'll probably switch to a set schedule, and then whoever can show up can show up. That's sort of where we want to go next. But I love that view of the one. So you're moving, taking us on a tour now.
Yeah, I'm gonna see if I can see the witch head.
So the question from Charles Wagner, or Wagner, I don't know which nation you're in, is there any science that can be done with backyard scopes, both individually as a single person or collectively? Yes, there's tons of it. So if you like variable stars, if you like watching stars that change in brightness over time or randomly explode, there's the American Association of Variable Star Observers. If you like watching asteroids and other minor bodies, there's the Center for Minor Planets. If you like watching planets, there's transitsearch.org. There are a whole variety of different observational programs that you can get involved in. There's the Center for Backyard Astrophysics if you like Novi. We're going to be working on collecting lists of all of these different projects that you can get involved in.
I have a friend up in Colorado that runs the Palmer Divide Observatory, Brian Warner, that does light curves.
Yeah.
I have no idea how he does it, but he's been doing it for a long time.
It's actually really, really easy to do. You need to have software like CCD Pro or Maxim DL, one of these things that allows you to measure the brightnesses of stars. But it's the type of thing where you just sit on the same field and you find a star in the field that is constant in brightness, and then you look at the star that changes in brightness, and you compare the difference in how bright they appear over time. And what you do is you actually make plot of that difference. And it's how I actually got my start. I remember sitting at Michigan State's observatory. It's a 24-inch telescope, and Horace Smith and I would freeze to death and thank God that hard drives stop working at -40. And it doesn't matter if it's centigrade or Fahrenheit. It's the same thing at -40. But we were out there on any clear night making these light curves.
He's been doing it a while, and I guess he finally has gotten actual funding through grants to do it with it. That's what he does. He just has 2 or 3 big telescopes out in his backyard, and that's all he does.
Yeah.
What I'm trying right now is the witch head, but it's a dark nebula, so with my hydrogen filter, we're not going to pull it out. So we'll try something else.
It's got the The double is that the double cluster in Heidi's? I've muted you, Cory. Sorry, you had a lot of background fuzz, so I had to mute you for a second there.
No, I think that...
That's the trapezium.
Yeah.
Hey, that's Orion.
That's the
Yep.
trapezium in Orion. Wow, okay.
Just so you know, that's the kind of... I just wanted to give you an idea of the field of view that I had.
Yeah, okay. Yeah, that's a
big field of view.
pretty big field of view. Yeah, I mean, F5 is a nice big
Yeah.
field. So you're sort of in the middle, right? I mean, it's such a wide field of view. You've got sort of half good for planetary and half good for some of the deeper sky objects. And with a big 10-inch telescope, that's a pretty nice.
That's going to be great this summer for clusters.
Yeah.
Yeah.
That's what my wife said. She's ready for the warm weather.
Yeah. Yeah, I can't wait for things like the globular cluster in Hercules and things like that. That'll be nice. Open cluster in yeah, that'll be nice. I think the camera is probably. I would see if you can try hooking up the. The other thing, there's a you're using Linux, right? I think there's some software that'll let you use your DSLR attached to your telescope and download the images, and then you could view those images. So it wouldn't be exactly real time in the same way, but you could be seeing the images as they were coming off the camera and displaying those in like 1 minute increments. So I would play around with getting an adapter from your camera to your telescope. They're not that expensive, like $20 or something like that. And
The T adapters?
Yeah.
Yeah.
And
My scope actually can't. I'd have to modify the scope to do that with my DSLR because
really?
of the back focus problem.
Okay. So there's your trapezium, and there's Gary's.
Hey now. I like Gary's better.
Just different views.
Different view. Yeah, you're not rubbing it in at all. Wow.
That's a 10-second. I'm doing it 1 minute right now.
Well, now, Gary, I can actually see the stars in the trapezium in my view, though.
Yeah. What can I say?
What frame rate are you using, Cory?
I honestly don't know right now. It's probably around 5 frames per second.
Yeah, so with faint objects like that, you definitely want to modify the frame rate on it. So you're going to try a longer exposure on this, Gary?
Yeah, I'm at 80% through a 1 minute exposure.
Didn't you find the 1 minute kind of blows it out a little?
Well, but I can stretch it a little farther. We get a lot more around the edges. And then I'll do a short one, and we can see the trapezium.
So we have Brian Lefkowitz asking, so if I start my journey to become an astronomer, I should be there when I turn 67, right? Well, that assumes you've never attended college and you're 57. So from graduating high school to having a PhD in astronomy, it took me 10 years. And the thing about becoming an astronomer is, when I was in graduate school at the University of Texas, we had a lot of people who'd had entire lives before they became astronomers. We had one man that was a couple classes behind me who was in his mid-40s. He'd actually worked on boats for the America's Cup race. He was a yacht builder, and he went on to become a telescope builder, and he was an amazing engineer. We had a woman in our program who'd been a laser jockey working at the John Glenn Research Center in Ohio, who decided that she wanted to move from working on lasers to working on telescopes, who joined our program. We had another woman she'd actually been a pipe fitter. She didn't think she was someone who could go to college, and in her mid-30s she realized she was a lot smarter than anyone had given her credit, and she was right. She was top of our class, went on to get an amazing fellowship. I'm not revealing who she is because I don't know if she wants the world to know she used to be a pipe fitter. But there were all of these fabulous older people in the program that also helped keep the rest of us young scrubs in the group from completely going off of our rockers due to stress and things like that. So you're never too old to restart. And the thing is, though, you don't need the degree. You can get involved through citizen science projects. You can get involved through your own career if you're in a science, technology, engineering, or math field. There's lots of different opportunities.
Okay, what I've got is I've Am I in there? Yeah, okay. I've totally blown out the center so that you can see all the wispy around the edges. Now I'll do a short exposure.
That's phenomenal. And so the object over on the right has a different designation, right? M42, and is it M41? M43?
And it's the Running Man Nebula, and I don't remember what the name of it is.
I thought it was like NGC 1976 or something. I could be wrong.
Yeah. I think, and I always forget this, a bunch of people ask sort of what's a good introductory scope, and I think, you know, there's two.
What Cory has.
Well, what Cory has is great for, but you can see the problem that Cory's struggling with, which is, you know, for the astrophotography, he's having a rough time. I would say my favorite setup of everybody here, sort of in a reasonable place, is what Stuart and David Riley have. They have 130 refractors, but really nice mounts. And, you know, so they're probably about a $1,500 telescope, maybe a little less. And they have a beautiful view of a lot of the planetary stuff and a really rock solid. The mount is everything, right? The mount is just tracks. And so
if you want to do photography, if you just want to look, get what Cory has.
Yeah. If you want to do visual astronomy, you want to get what Cory has. If you want to do astrophotography, then I think what Stuart has is one of my favorite setups. I'm going to invite I can see that Emily Locknawala is watching, but if I see a planetary scientist watching, I want to put them to work. So
Poor Emily.
It's completely optional, Emily. You don't have to
run away. No, seriously, we'd love to have you in here.
So what scope camera? So Dave Gallant wanted to know what you're using. So Gary is using a 14-inch Celestron with a fast star setup. So what's got is he's got his camera hooked up to the prime focuser on his Celestron. So normally with a Celestron, the light comes in the front, bounces off the back. Then there's a secondary mirror inside. It bounces off the secondary mirror and goes out the back, and then that's where the eyepiece is. And the nice thing about these Celestrons, these Schmitz cascades, are nice and short, really stubby telescopes, easy to move, whatever. But what Gary's got is the light comes down inside, and it bounces back off that back, and then he's got his camera right at the front of the telescope. So you know, if you see his telescope moving around, the camera is actually mounted to the front of the telescope, which is pretty unusual. But so what that does is it takes what's normally a fairly narrow field of view and widens it out. And so he's got what's called an f2, which is a very, very wide field of view. And the funny thing is, if you notice, we've been asking Cory to show us Jupiter, which he's doing valiantly there. But we wouldn't ask Gary to do it because, in fact, his setup is just too wide a field, and so Jupiter makes this tiny little spot. And so we're now joined by Emily Locknawala, who was watching. Hi, Emily.
Hi.
I'm going to have to keep my microphone muted most of the time because there's a lot of chaos going on. It's family night here, but I'm happy to answer any planetary questions that you may have.
And I can see your young astronomers beside you.
So what's up?
One thing about, we've talked about f-stop, and that's the ratio of the mirror to the focal length. So on my scope, it's a 14-inch mirror, and the camera is 28 inches in front of the mirror.
Right.
And this is my trapezium.
So do you want to try the Horsehead now?
We can do that.
It's pretty close.
It's always a good one.
Yeah. Unbelievable sort of what kind of a view. I'm still getting some background fuzz. I'm going to move you over there. So, yeah. Unfortunately, we don't have a. We had. Well, I don't know if you can see. the bands across the planet, but we don't have a view of Mars tonight, Emily, or the Moon. So, that's where you'd be able to help us out.
But we have
not even Venus or Jupiter.
We've got Jupiter there right now, which is in the view right now. It's a little bright. This is the one. So Cory is hand guiding his 10-inch Dobsonian on Jupiter right now. And so you can see there. You can see the bands now, I think, on the planet.
Yeah, that looks good.
I'm actually shooting through my neighbor's tree right now.
I can see that. Yeah, it's dimming. It's losing the view.
So we do have a planetary question popping up. Is Mars really a viable habitat for humans? What evidence is there that humans can survive long-term in such low gravity? I'm not sure it's the gravity I'd worry about.
Yeah, I don't know. There's a host of problems with traveling to Mars, of course. I just want to check. I'm getting audio through my speakers. I want to make sure that it's okay, that there's not problems with audio and echo. Is that okay?
I'm not getting any echo from you.
Excellent. So yeah, like Pamela said, I think probably gravity is the least of your problems, because 38% gravity it's really not that bad. I think that greater problems are just making sure you have enough oxygen and water and that your life support doesn't ever fail. And also, dust is really a big problem on Mars, as we've seen with the solar panels on Spirit and Opportunity. That dust, it's not just that it falls on things, and it's not just a matter of wiping it off. It's so tiny, and it's made of these clay minerals that are very flat, so it electrostatically clings to everything. It would get inside everything, and I think that would probably actually be one of the biggest problems facing anybody trying to live on Mars.
One of the most fascinating interviews I've ever done, and it was one of these where you're not sure you can prevent yourself from laughing while you're interviewing the person. There was a woman whose research down at Johnson is to take freshly harvested pig hides, irritate them with artificial moon dust, which is another problem that we have to figure out how to mitigate, and basically put pig flesh, moon dust, various type of fabric they're considering for clothing, irritate and see which one harmed the pig's skin fastest, and they've determined that polyester may be the superior fabric.
This kind of stuff is why I'm a geologist. I like physical reality. I like interacting with rocks. I like climbing mountains, but ew.
Yeah.
But it does go to show you could have any degree in science, still work for NASA.
I want to just stop for 1 second and gaze at that beautiful view of the Horsehead Nebula.
Yeah.
Look at that. That is just astounding. This is live, remember, so that's what it actually looks like right now with that telescope. So, and I love the fact that is it just a complete fluke, Gary, that the orientation of your telescope happens to give us, or your camera happens to give us that view of the Horsehead properly lined up and down?
Yep, just the way things are lined up.
And so what's that star that's on the right?
That is, I never remember the name, but it is a left-hand star in the belt of Orion. Aniac?
Eneltac?
No.
I can't pronounce anything. That's been determined tonight.
Is it Alnitak?
That sounds right.
Alnitak?
Yeah.
Yes, it's the pronunciation we're curious about.
Yeah, so if you go out to, if you go outside and you look at Orion, you can see this, well, you can see the star for sure, and then the nebula is sort of surrounding that star, but you won't be able to see it with your own eyes. I don't know. No, you wouldn't be able to see it.
No.
You'll be able to see
You can't even see this one with binoculars.
You can't even see that fuzz. And then what's the fuzziness on the bottom right then?
That's a different nebula whose NGC number I don't have.
It's called the Flame. I don't know the NGC.
But what's kind of awesome about this is a system that was first recorded back in 1888 by Wilhelmina Fleming, and so this is part of the Harvard College glass stacks where you can actually go and look at the discovery plate that Wilhelmina looked at when she found this. It's still on storage at Harvard College Observatory.
So,
wow.
we've got a special request, Gary, which is Sharon Ahmed wanted to know if we can try and see comet C2012 C2 Brunhaze, which is, I guess, was recently discovered. And
I'll stick the coordinates into the chat for you.
Not the coordinates.
Okay.
Yeah. So here's the
I
coordinates.
appreciate that.
Do you know anything about this, Emily? Oh, you're muted.
What was that?
Oh, do you know anything about this comet? This 2012 C2? No.
Not specifically, no.
No. Okay. So I actually hadn't heard about this discovery, so I don't know if that's going to be in your field of view, if that's going to be up for you. I'm not sure where that even.
Yeah, is Roy Sanders online? He wrote an article about this a couple days ago.
Yeah, isn't this the one they just found like a week ago or something?
Yeah, yeah. So this is a brand new. Okay, we'll see you later.
Or he
Is it-
shared an article on it, rather. Sorry.
Is it going to be up in our sky is the question.
I think Ray is teaching astronomy tonight.
Okay.
So, yeah. So we put the coordinates in to give to Gary, and he's going to see if he can put that into his computer. And sometimes what we get is the telescope swings around and points at the ground, so we know we're not able to see it. So what's causing that darkness in the Horsehead?
It's the same thing that we saw with the Comet Nebula. That's an area of extremely thick dust and molecular material that's just blocking the light from passing through it.
But is there something special that's going on? Is something giving off that dust?
No, the universe is just, it starts off filled with stuff. And then some of that stuff gravitationally collapses and forms clouds. Some of that stuff gets blown apart. So this is just one of the entire universe started out opaque and filled with things, and then from the age of reionization forward, we've been emptying out the universe through gravitational contraction, and this is just one of the areas that's still dense and hasn't yet formed a star. The true story of the evolution of the universe is one of from solid to lace, basically.
Like we can't pronounce anything. Oh, so it should be near Jupiter.
Okay. I'm embarrassed to admit this. I'm trying to remember how to enter coordinates.
Yeah, Brian, who just made a comment on how we can't pronounce anything. The problem is, I was that special kind of nerd that read everything, and when I hit a word I didn't know how to pronounce, I just kind of made it up and moved on with life. And now I'm an adult who still hasn't learned better, and I'm working on it.
What star is that?
There you go. So Sean has given us a link to an article on Universe Today
Serious.
about the discovery. Not one that I wrote. So.
2430.
Oh, that's serious. Oh, cool. That's the brightest star in the sky.
And that's why I can show it to you with my cheap webcam.
So the spiky bit that you see going up and down and left and right, that's actually caused by the spider that's holding the mirror at the front of your telescope. So the light comes through, passes around the mirror at the front of the telescope, hits the telescope at the base, hits the telescope that's actually angled sideways, and then the light comes out an eyepiece and gets captured by his web camera. But you have to have something holding that mirror, and it has 4 spider legs coming off of it that cause these beautiful diffraction patterns.
The interesting thing is that people that don't have those spider veins will add those post-processing. They will add those spikes so it looks like a star.
And you can actually buy filters for your camera just to add that effect.
That's cool. What about Andromeda, Cory? Can you get Andromeda?
Oh, I could try, but it would be, yeah, no.
I wouldn't even try. Yeah, I think
light pollution's bad enough. for that.
Yeah,
So
I think you need the moon is what you need.
yeah, exactly.
If you're not able to get it, it's no problem, Gary. You know, that's
No, it's just on this hand controller, I never remember how to enter a plus sign instead of a minus sign for the declination.
Have to get you a computer hookup.
Yeah.
So Gregory Strike says he came inside from looking at the Orion Nebula with the binoculars. So I think that was great. So you were outside looking at Orion with your own binoculars, and you came in and saw this.
So at Black Projects over on Twitter just shared a great link to, I think it's the website of the person who discovered the comet, and I'm going to put it in the Google Hangout comments so that everyone on both sides of the, I don't know, branding war can take a look at the article.
Is this the one on moonglow.net?
It's, yeah, moonglow.net.
Yeah, there's someone just posted it already there.
Okay.
You don't have to.
It's there now twice.
Okay. There you go.
So Eli Mendez asks, could they build telescopes with transparent legs to mitigate that spider effect? The problem is pretty much nothing is really transparent to light. So you can imagine using plexiglass or something like that that optically would seem a little bit more transparent, but it's still going to cause some sort of an effect. One of the problems that we run into is there's also a reflection problem anytime you have a surface. So there'd be something going on no matter what happened, both a strange bending of light around it and a removal of light because some of it got reflected. There's just no way to make something truly transparent unless you find a way to hold the mirror there with magnets, and that offers all sorts of stability issues.
So
real quick, while you're on that, mine has a corrector plate in front, which is a lens, so I don't have the
Yeah.
arms holding it, but you get this kind of an effect right here. On something bright, I get light bouncing back and forth inside the telescope. So I don't have diffraction spikes, but I have that.
I'd like to see 2 more objects, Gary, if you could be so kind.
Yeah, let me grab a 10-second of this comet. I want to leave that one up there for a second.
Oh, so you were able to find navigate to it?
Yeah, my thumbs figured out what to do.
You can work that computer. and I'm not sure what Cory's got a view of right now. I see a couple of stars. A double star?
That's Betelgeuse.
There it is.
This is one of the biggest, reddest objects in the sky, and when I say big, it's actually large enough with some of the telescopes down in Arizona we can start to resolve the disk of the star and make out giant sunspots bigger than our own sun. It's one of the shoulders of Orion, and it, along with Eta Carina, is one of those stars that people like to say is going to go supernova any day now, which means sometime in the next few tens of thousands of years. Tomorrow or
a
long time.
I don't see it.
No, that was a 10-second. I'm doing a 1 minute right now, but I don't. Yeah, and especially through the hydrogen alpha filter.
Oh.
Yeah. It had a greenish
You may not
glow
get
to
it.
Yeah,
I'm not sure what would be giving off H alpha.
Just the reflection from the sun, because I know the sun gives off a lot of H alpha. But
What
we'll see.
We're normally used when you're trying to look at a comet?
Broadband or none. Actually, sulfur filters for really close ones. You can sometimes get sulfur tails, which is just kind of cool.
So that's a minute.
Yeah, I don't see anything in there.
Yeah, I think you just have the wrong filter.
Yeah.
You probably wouldn't have discovered it.
Go ahead, make my day. All right, what was your request?
Well, no, I mean, do you want to try maybe switching filters on it, or switching to your clear filter?
The clear filter is going to be way out of focus.
Right. It's a different length. So do you want to try the sulfur one then, Pamela mentioned?
I don't know if this one has sulfur tails, so it would be a wild goose chase.
Well, what the heck? We'll do a 1 minute oxygen.
Okay.
And see if that shows us anything. And what was after this? What was the other one you were looking for?
Well, I wanted to see Andromeda and the Trifid Nebula again.
And we have a request for the Hourglass Planetary Nebula.
Okay.
So easy. No problem.
Poor Roy has clouds. We miss your telescope, Roy.
So do I.
Absolutely. I had rain here yesterday. I didn't know if it was going to clear up or not.
I had a little bit of rain yesterday.
But Roy's actually got his observatory, and so he's got to drive to it, and he can only go on the weekends.
Oh, I would have tried. I would have called in sick.
Well, maybe we need to schedule a special Saturday night one.
Yeah, well, like I said, I think, I tried to average out everybody's schedules. I posted to our big Star Party team and said, what day works for you? And I got completely different days from everybody. So
Yeah.
No, there were two of us that both objected to the same sets of days.
Yeah, I should have known better. So, but is that it?
It's possible. I can't resolve it enough to tell, but there's something right there.
Yeah.
See if I can squeeze it a little bit more.
That looks comedy.
Yeah, that's about the best I can stretch it. My guess would be that's it.
There you go.
But
you discovered a comet.
All right, so you want the Great Andromeda.
Yes, please. Well, we've got this request for the Hourglass Planetary Nebula. Is that visible right now?
I think so. Okay, here we come moving to Andromeda. Oh, that's right. I forgot it was in that direction.
You won't be able to get the hourglass. It's below the horizon.
Oh, is
Okay.
Okay.
Sorry, Brian.
Okay, I'll start with a 10-second of Andromeda.
This is always a crowd pleaser. Actually, that Trifid one I think is the most phenomenal object. It's as if someone, it's like your telescope field of view is exactly perfect for showing. That 10-second is really good tonight, actually. I can see the dust lanes in that view already.
Mm-hmm. Now we're looking at that. I'll give it a 1 minute.
That is phenomenal.
Yeah, my skies are gorgeously clear. There's just a lot of movement going on.
Like you've got a lot of wind?
Yeah, with the Santa Ana conditions in the area. So I'm kind of shielded from it here, but up in higher altitude, I know it's blowing like mad, and that doesn't help light passing through.
Oh, and for anyone who's watching this right now, we're going to be doing an interview with Mike Brown from Caltech tomorrow. Mike Brown is he's the person who discovered Eris, and he's also known as the Pluto Killer. So I guess discovering Eris led to Pluto being unplaneted. So we're going to be doing that tomorrow at 10 a.m. Again as a Google Plus Hangout. We did last week. We talked to the Mars rover driver Scott, and so so tomorrow we're going to be talking to Mike Brown, which will be great. And that's going to be at 10 a.m. Pacific, 1 Eastern, and 6 p.m. Greenwich Mean Time.
And it will be on the CosmoQuest Hangouts for those of you who like having Twitter there as well as the comments.
Was it not the Trifid? Which was the nebula that we had? The big one. It was the Rosette, right?
The Rosette.
The Rosette, yeah,
Yeah.
not the Trifid. Sorry, the Rosette Nebula, yeah.
Because I just look and the Trifid's not up.
Yeah, no,
Wait, yeah, that's why I thought maybe you meant the triangulum.
no, I meant the Rosette. The Rosette.
And Cory's being an awesome trooper, keeping Betelgeuse in there.
Waiting for it to explode.
It's serious again.
Oh, that's serious again, yeah.
Okay.
It's
So
prettier
there
than
is,
Betelgeuse.
Okay.
Can you get the double-double in the Big Dipper? Or is that too low down on the horizon for you?
Oh, there we
For
go.
me,
For Cory.
Cory.
I'm not sure. I'm gonna have to go and look. Hold on
Okay.
1 second.
Oh, that's phenomenal. So you can see the dust lanes in. So this is M31.
M31.
M31, yeah. So this is the great Andromeda galaxy, which is on a collision course with us, and will collide in the next 8 billion years or so, and form a giant elliptical galaxy with us. And you can see its little satellite galaxy just off to the right of the view. And I think what's amazing with this view, you can see the dust lanes around the galaxy. I'm pointing at my computer, which I guess doesn't really help anyone. But you can see, yeah, there's the dust lanes, and then as well, you can actually see just at the bottom right-hand corner, you can actually see some clusters and nebulosity in the dust lanes as well. So the star formation and star clusters, and yeah, what a phenomenal view of that.
And his field of view is only about a degree. It's more than a degree across the diameter. But all of Andromeda, if we could take in the visual light extent of it, is actually about 3 degrees across, 6 times the diameter of the moon on the sky.
Yeah, it's just a gigantic object, and you can see it with your unaided eye. So if you go outside and you know where to look, and you've got nice dark skies, you can see a fuzzy bit in the sky, and that's Andromeda.
And I'll make a comment here to Mike Richter. I'll sell you insurance for galaxy collision. Happy to. Okay, we happy with that? Rather transit to the Rosette?
Sure. Yeah, that would be great. If you could do the Rosette, that would be fabulous. What is NGC 2392? Did we do that already? Let me see. Guru Stu wanted to know.
2392.
I'm just going to check on the internet and see what that says. Oh, the Eskimo Nebula.
Someone on Twitter just totally made my night. They said, skipping Jersey Shore to attend my first star party. Yes, that's awesome.
Perfect. What constellation is it located in? It's in Gemini, so it should be up. Gemini's going to be coming up for you, isn't it?
Let me look at it on my chart.
But
It's 2392.
yeah.
Yeah, it's
Okay.
up.
Okay, we'll give that a crack as well. So you're doing the Rosette first?
Yes.
All right, this is my favorite. Which filter? Do you have the hydrogen alpha filter on it right now?
Oh, good question. No, I left it at oxygen. No wonder
what I
it's not
thought,
showing
yeah.
up.
You know, that's interesting. The galaxy looked quite different than what it normally does, and so I think that's because you had that oxygen filter on it, not the H2 alpha one.
Mm-hmm. Okay, and that's just a 10-second. I'll do another 10-second. I can see it a little bit here.
Yeah, but you can leave it on this filter for a second so people can see, and then if you switch it to the H2 alpha, it's a whole different view. Very cool.
Yeah, I actually already switched to the hydrogen.
Sure. This is my favorite object, which I think hopefully everyone will see in a second.
Let me
Why?
bring it up a little bit.
But it's my favorite object that Gary is able to bring up.
Okay. We keeping you awake?
Yeah.
I've been really sick all week, so it's been this careful balancing of enough medication that I'm not sitting here coughing and wheezing and runny-eyed, and not putting myself to sleep or making myself hyper. And I feel like I'm playing with chemistry, and
Okay,
I
well then-
didn't do well in chemistry.
All right, well, let's wake you up, Pamela. Austin Go wants you to explain the moon illusion. Go.
Oh, geez. Okay, it's just a matter of perspective. Our brain interprets the size of things based on what they're beside. So you can imagine that you take a picture of a perfectly formed miniature Doberman pinscher next to a miniature fence, and that picture will make you think that it's a normal-sized dog and a normal-sized fence. But then you take that same exact dog and put it next to a bigger than normal scale fence, and suddenly your miniature dog looks like a teacup dog. Well, with the moon, when you see it high in the sky, your brain has no clue what to latch onto to give it size. And so you lose it in the vastness of the sky, and it appears fairly small. Now you put it low on the horizon, and suddenly you're seeing it next to very distant and thus small appearing objects. And so the moon appears to be very large. And it's just your brain trying to provide information it doesn't actually have.
And so one of the cool ways to sort of test this out for yourself is when you go outside and you see the moon right close to the horizon, gigantic, blood red moon, hold your arm out and hold up your hand, and your fingernail on your pinky will just cover the moon. That's the size, or as people say, an aspirin held at arm's length. And then later on in the evening, when the moon has come up right up to the sort of the zenith, then do it again. Hold your hand out, arm's length, and you'll see that it's exactly the same size. So it's not that the moon is bigger when it's close to the horizon and smaller when it's high up. It's just that your brain is getting messed with.
So the
Look at that.
atmosphere has no refraction that make it bigger, like a magnifying effect?
Not meaningfully. I mean, refraction does change where it appears on the sky, but it doesn't really change the size of it.
So this is the Rosette Nebula.
That's a Rosette at 10 second. Here it is at 1 minute. Let me
Bright.
readjust. Yeah, a little bright. No problem. We're getting there.
Oh, that is just phenomenal. So you can see why this is my favorite.
There we go.
Yeah.
That's a pretty good shot of it.
Oh, fabulous.
I love all the little fiddly bits in here.
Yeah.
And each one of them could hold many of our solar systems.
Yeah. Yeah, those are all the densest regions in the gas that have collapsed and been blown together, depending on how you want to look at the process.
Slarty Bartfast must have done this part.
Is that from Hitchhiker's Guide to the Galaxy?
Yes.
Galaxy.
Right. That is phenomenal. Wow. I think it looks even nicer tonight than it did the last time we looked at it.
Yeah.
You've just got really nice clear skies tonight.
Here's one for you, Fraser. How about NGC 281?
NGC 281. What's that?
It should be visible.
Well, we're going to hit 2392 next, so is everybody taking that one in?
Yeah, everyone, oh, that'll be nice.
2392.
All right. Moving on. Sure, it's fantastic, but, we don't have a lot of time. Let's keep moving.
We be moving.
Let's see. Eli Mendes said it would be cool to set up a network of telescopes, internet-connected telescopes that would be available for random internet users to select direction when the owners of the telescopes aren't using them. So there's two things you should look at, Eli. There's a thing called SLOOH, S-L-O-O-H, and these are some automated telescopes that you can buy time on and be able to access them. And then there's another thing called the Night Skies Network. Night Skies, the NSN, the Night Skies Network, and that is a collection of hundreds of telescopes, all at various times they come online and are doing observing, and you can interact with them and chat with them and talk to them. So So those are a couple of options. Nobody really.
There's global rent-a-scope as well if you want to get your own dedicated time, or if you join the American Association of Variable Star Observers, which I think is $70 a year. I've lost track of the exact cost, but it's like tiny amount of money for being allowed to get time on their entire global network of telescopes.
Yeah, and Eli Mendez wants to know plans for Southern Hemisphere Star Party Hangouts. Absolutely. I've been talking with a couple of people in the Southern Hemisphere to work with them, and the plan is for it to be a global star party. So we want to have telescopes in the Northern Hemisphere, telescopes in the Southern Hemisphere, telescopes during the day, all happening at the same time. And so we've got stuff in the early morning, stuff at late at night, stuff at, and the sun all at the same time, which should be possible. It's really just a matter of us just getting the word out, getting more people involved, helping people. Each person we start out and they've got a telescope and we talk, we help them get their gear set up and we help them stream into the Hangout and coordinate and deal with the audio issues and we're sort of, we're all learning as we go and working as a team. So in the, we've got a couple of experiments we want to do. Probably in March, we're going to try and do a Messier marathon, but we're going to try and do like an instant Messier marathon. So we'll try and do all the Messier objects in like 2 hours, just, with 5 astronomers all working at the same time. We're going to do the, we're going to be live streaming the transit of Venus, which is going to be in June, and that's going to be a once-in-a-lifetime event. But, and as well, as we move through the year, different objects are coming up at different times. I mean, Mars is, probably very low on the horizon, even for Cory right now. People on the East Coast can see Mars coming up now. If you go outside right now, if you're on the East Coast, go outside, look to the east. That object that you can see is Mars. So as we kind of move through the year, we'll get different objects at different nights. So yeah, definitely we've got big plans for this.
And I have to correct Fraser. The Venus transit is a twice-in-one-lifetime event if you happen to have caught it a couple of years back. I unfortunately was getting rained on.
Right. Same here. Well, no, I've lived on the wrong part of the planet.
Okay.
Yeah. So
I'm looking forward to the Venus. I get about 3, maybe 4 hours worth of it, so it's gonna be pretty cool.
That's
so
awesome.
are you in, Roy? Is that you saying that you're in?
Oh yeah, I'm in.
All right.
Cool. It's on a Tuesday, but I'm there.
Yeah, I don't think, Gary, I think this would ruin your telescope.
I'd have to have a very big solar filter.
Yes.
Mine's on order. I know Stuart just got his.
Yeah. Oh, good. Okay. No, John Voicey has a solar filter, so we'll have for sure a lot of telescopes doing that. So I don't see it. This is the Eskimo Nebula, right?
Yeah, it's too small. I think that's it right there.
What's your exposure time right now?
10 seconds. I'll do a 1 minute just to see if we can pull something else out. But I know I've tried to look at it before and couldn't find much.
So did anyone watch the Hangout that they did from CERN earlier this week?
No.
You see that? No, they had the Hangout on Air. It was actually run by Google, and they had somebody standing in front of the collider, live streaming and talking about the experiment, and they had other people joining in as well around the world. It's really neat. So I can't wait to see some of the more really cool experiments as people figure this out.
Okay, we're coming up on 70%.
Yeah, I don't think you're going to get it.
I don't either. I got too wide a field of view.
Yeah, it's really tiny.
So Fahad Alzawaid, are we live streaming from the scope or taking pictures of the sky? We are doing kind of somewhere in between. So with Cory's view, he is live streaming, so it's running about 5 frames a second, and he's got a double star there, I think.
Yeah.
Which is great.
I think that's actually a 4-star system. That's the double that's in the Big Dipper.
Oh, right.
It's the second star in the handle?
Yeah.
So each of those stars is actually 2 stars.
And then with what Gary's doing, because he's looking at fainter objects, he's having to take timed exposures. So he's getting between 10-second and 60-second exposures with his telescope. And so that's how we're getting these views. So I don't.
My best guess is it's right here.
Maybe it would be fainter. I'm not sure.
Possibly it yeah. I don't know. It's been a long time since I tried to track it. What else did you have on deck?
So we've got NGC 281.
281.
And this is in Cassiopeia.
It's one of my favorites because it's the Pac-Man Nebula.
So while they're repointing, the double-double that Cory has, this is the stars Mizar and Alcor. They're in the handle of the Big Dipper. And to my eyes, which aren't great eyes, it's just a single star if you go out and you look at the constellation with your eyeballs. But there used to actually be, I can't remember which military it was, there was a military test for elite soldiers. They had to be able to split these two stars with their eyes.
I believe it was the Roman military a long time ago.
I mean, that's
Obviously, a
just
long
kind
time
of
ago.
cool. Yeah.
They were hardcore. Wow. So the object we're going to be looking at, as you can see, Gary's telescope shifting over to the new target. And so this is the Pac-Man Nebula.
Oh, yes.
How big is it?
I'm trying to remember. I've taken it.
I'm
Let's
seeing.
Like 35 degrees.
Whoa.
Or 30, well, not 35 degrees. 35
minutes.
Minutes.
35 minutes, yeah.
Yeah, so about half a degree.
Yeah, so it should be. I know I've taken it. I just don't remember.
So this is a region of ionized hydrogen gas that within it has several really dark clouds of, again, molecular material. So there's a young star-forming region inside of it.
Unfortunately, the moon is.
There it is.
So Charles Wagner wants to know, any possibilities of getting any major observatories involved with a star party hangout, say Peak or Mauna Kea? Yes. Yes.
Sort of.
Yes, there's sort of. The problem is that their setups are actually not that useful for this. They're more specialized for science, and so the kinds of views that we would get from some of those really big telescopes wouldn't actually be as entertaining as even what we're getting from Gary. So, but what we have had offers from some of the people is the astronomers working at those observatories have their own telescopes set up under those same really amazing clear skies at the tops of mountains, and they really know their stuff. So I think what we're gonna try and get is some professional astronomers who are, while the computers are whirring away, pulling in images with the big telescopes, they're going to be outside with their smaller telescopes, giving us a really nice view. So actually, I think you would find that those big telescopes would actually be a little bit disappointing.
No, that's not true.
Well,
I used to use them all the time. No, but the big difference that we're running into is once you start using the big telescopes, to get time on them, it's a competitive process. So Fraser and I would have to submit paperwork to the major observatory.
I'm out.
Right. The second paperwork is mentioned, it becomes my problem.
Yeah, I'm out.
This has happened over and over. I'm good at paperwork. So I would be submitting paperwork. I'd have to convince the people that my justification of using the telescope for y'all is just as valid, as important as what they would normally be doing. And I've won this before. I used to take students out to the 30-inch and the 82-inch at McDonald Observatory once a year. And then beyond that, one of us would probably have to travel to the telescope to use the telescope. That's, again, me. And I'd have to come up with funding to do that. So we're now looking at it's a few $1,000 endeavor.
Yeah.
To hit a cloudy night.
To hit a cloudy night.
And I'm the queen of cloudy nights.
But
But this is the type of thing where I might contact people who are already at some of these observatories, someone like Bill Keel perhaps, and see if when he's doing his science observing, he'd be willing to stream his taking pictures of overlapping galaxies or something into a Hangout.
Yeah.
One of the neat things my club does, I have not been able to attend, but I think I'm going to go this June, is they rent the 60-inch telescope on Mount Wilson.
Yeah.
You know, $1,500 for a night, and you can have 20 people or so. And that's got to be phenomenal. All right, well, here's a Pac-Man.
Nice.
And you can actually start to see it nomming on the things. It's going down towards the corner of the screen.
That's fantastic. Well, I think we're running out of things to see. So if you're watching this, if you could do a favor and +1 it, if you're watching it on Google Plus, and that will help us know how many people are watching it. Yeah. Oh, so Gregory wanted to know what are some of the organizations that let you purchase time on the telescopes? So SLOOH, SLOOH.
I think there's like light buckets or something too.
Oh, yeah.
I can't remember the exact name.
Global Rentoscope is a good one. And like I was saying, if you just join the American Association of Variable Observers, they have a network of telescopes that you can apply for time for, and using those, that's free, that's part of your membership, and they'll teach you how to do science, and that's one of the more awesome parts is it's not just about looking at pictures, it's also about rediscovering our universe.
Well, this is just phenomenal. So, so unless we've got any more requests, I think we should probably wrap this up now. So once again, thanks as always to Gary for the phenomenal views of the telescope, and thanks for coming with some an agenda. It was great to have a few of things that you had thought to look at, which was, I mean, that Thor's helmet was phenomenal. I've never seen that before. So. And I've never seen the Pac-Man Nebula before, so I'm really pleased. So thanks again, Gary. Really appreciate it.
I think I had me muted. There it is.
There you go.
I appreciate it. This is a whole load of fun, and there's a whole bunch of other stuff up there, and I'll do a little research.
Yeah, that's fantastic. Yeah.
I wanted to preview these beforehand, but this is the first clear skies I've had since we did the last one.
Really? Wow. Okay. And thanks again to Pamela and Cory. Thank you for your manual guiding there. I know your view when we get the moon. That's when you really blow people's socks off. We've seen most of the viewing we've done with Cory has been with the moon, but right now the moon isn't up yet. So it's that's the great view. So thanks, Cory, and thanks for showing us Jupiter. I'm looking forward to more. Yeah. And thanks, Roy. I know you're away from your observatory, but it's great to have you as always. And thanks, Emily, for heeding the call. That. And thanks, Pamela, for explaining the science. So I'm Peter Payne. I'm the publisher of Universe Today, and thanks to everybody who joined us for tonight's live streaming telescope party. The plan is next Thursday to try again, 6 o'clock Pacific, 9 Eastern. I don't even know what time it is in London.
9 Eastern is 2 a.m.
2 a.m. London? Yeah. So we'll give you some more notice this time. We're trying to move away from crazy experiments to something that you can kind of set your watch to. So that is the plan. So again, thanks for everyone watching, and we'll see you guys all next time.
All right, everybody. Thanks.
Bye-bye.
Bye.